Natural numbers are a part of the number system, including all the positive integers from 1 to infinity. Natural numbers are also called counting numbers because they do not include zero or negative numbers. They are a part of real numbers including only the positive integers, but not zero, fractions, decimals, and negative numbers. We see numbers everyone around us for counting objects, for representing or exchanging money, for measuring the temperature, telling the time, and etc. These numbers that are used for counting objects are called natural numbers. For example, while counting objects, we say 5 cups, 6 books, 1 bottle, or etc. So, what are natural numbers? Natural numbers refer to a set of all the whole numbers including zero. These numbers are significantly used in our day-to-day activities and speech. Natural numbers are the numbers that are used for counting and are part of real numbers. The set of natural numbers including only the positive integers, either 1, 2, 3, 4, 5, 6, and so on. Example of natural numbers. Natural numbers, also known as non-negative integers, all positive integers. Few examples include 23, 56, 78, 999, 10,202, and so on. So, next, set of natural numbers. A set is a collection of elements or numbers in this context. The set of natural numbers in mathematics is written as 1, 2, 3. The set of natural numbers is denoted by the symbol n. N is equals to 1, 2, 3, 4, 5, and so on. So, the statement form, n is equals to set of all numbers starting from 1. And then the roster form, n is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. In set builder form, n is equals to x is an integer starting from 1. The smallest natural number is 1. We know that the smallest element in n is 1 and that for every element in n, we can talk about the next element in terms of 1 and n, or which is more than that element. For example, 2 is 1 more than 1, 3 is 1 more than 2, and so on. These figures shows the natural numbers from 1 to 100, which is all positive numbers. Is 0 a natural number? It's a no. 0 is not a natural number because natural numbers are counting numbers. For counting any number of objects, we start counting from 1 and not from 0. From odd and even natural numbers, the odd natural numbers are the numbers that are odd and belong to the set n. So the set of odd natural numbers is 1, 3, 5, 7. And for even natural numbers, the even natural numbers are the numbers that are even exactly divisible by 2 and belong to the set n. So the set of even natural numbers is 2, 4, 6, and 8, 6, 8, and so on. The set of natural numbers is the same as the set of natural numbers, except that it includes an additional number which is 0. The set of all numbers in mathematics is written as 0, 1, 2, 3. It is denoted by the letter W. So W is equals to 0, 1, 2, 3, 4, and so on. So from the definition, we can understand that every natural number is a whole number. Also, every whole number other than 0 is a natural number. And we can say that the set of natural number is a subset of the set of whole numbers. Natural numbers are all positive numbers like 1, 2, 3, 4, and so on. They are the numbers we usually count and they continue till infinity. Whereas the whole numbers are all natural numbers including 0, for example 0, 1, 2, 3, 4, and so on. Integers include all whole numbers and their negative counterpart, either negative 4, negative 3, negative 1, 0, 1, 2, 3, 4, and so on. The following table shows the difference between a natural number and a whole number. Where in natural number, the set of natural numbers is n is equals to 1, 2, 3, and so on. And while in whole number, the set of whole numbers is w is equals to 0, 1, 2, 3. So the smallest natural number is 1 and the smallest whole number is 0. Then all natural numbers are whole numbers, but all whole numbers are not natural numbers. Each whole number is natural number except 0. This set of natural numbers and whole numbers can be shown in the number line as given. All the positive integers or the integers on the right-hand side of 0 represent the natural numbers, whereas all the positive integers along with 0 represent the whole numbers. So there are properties of natural numbers. The four operations of natural numbers are in addition, subtraction, multiplication, and division on natural numbers led to four main properties of natural numbers as shown below, which are closure property, associative property, commutative property, and distributive property. So first we talk about closure property. The sum and product of two natural numbers is always a natural number. So closure property of addition, this is the formula. So a plus b is equals to c. So for example, 1 plus 2 is equals to 3, 7 plus 8 is equals to 15. This shows that the sum of natural number is always a natural number. So in closure property of multiplication, so the formula is a times b is equals to c. So for example, 2 times 3 is equals to 6, 7 times 8 is equal to 56, and etc. This shows that the product of natural numbers is always a natural number. So the set of natural numbers in n is closed under addition and multiplication, but this is not the case in subtraction and division. So next we talk about associative property. The sum or product of any three natural numbers remains the same even if the grouping of numbers is changed. So this one is the formula of associative property of addition, which is a plus multiplied by b plus c is equals to a plus b multiplied by c. So for example, 2 plus by multiplied by 3 plus 1 is equals to 2 plus 4 is equals to 6, and the same result is obtained in 2 plus 3 then multiply by and adding 1 is equals to 5 plus 1 is equals to 6. So in associative property of multiplication, this is the formula a multiplied by b then multiplied by c, which is transformed into a times b times c. So for example, 2 times 3 times 1 is equals to 2, then 3 times 1 is equals to 3. So 2 times 3 is equals to 6, and the same result is obtained in a times b times c is equals to 2 times 3 times 1 is equals to 6 times 1 is equals to 6. So the set of natural numbers n is associative under addition and multiplication, but this does not happen in the case of subtraction and division. Okay, so let's continue to the commutative property. The sum or product of two natural numbers remains the same even after interchanging the order of the numbers. The commutative property of n states that for all a b to the n, a plus b is equals to b plus a, and a times b is equals to b times a. So in commutative property of addition, this is the formula a plus b is equals to b plus a. So example, 8 plus 9 is equals to 17, and for b plus a is 9 plus 8 is equals to 17. While in commutative property of multiplication, this is the formula a times b is equals to b times a. So for example, a times 9 is equals to 72, and 9 times 8 is equals to 72. So meaning the two natural numbers remains the same after interchanging the order of the numbers. So the set of natural numbers n is commutative under addition and multiplication, but not in the case of subtraction and division. Okay, let's proceed to distributive property. The distributive property of multiplication over addition is A times B plus C is equals to A times B plus A times C. So like for example, so the formula is A times to the B plus C is equals to A times B plus A times C. So for example, A is equals to 3, then B is equals to 2, C, while C is equals to 5. So we follow the formula. So 3 times to the 2 plus 5 is equals to 3 times 2 plus 3 times 5 is equals. So first we're going to multiply the two given. So 3 times 2 is equals to 6. Then 3 times 5 is equals to 15. So we add these two numbers, which is 6 and 15. So 6 plus 15 is equals to 21. So while in the distributive property of multiplication over subtraction is A times B minus C is equals to A times B minus A times C. So for example, so this one is the formula of a multiplication of distributive property. So A times B minus A times C. So we have an example. So A is equals to 4, B is equals to 2, and C is equals to 3. So 4 times, so we follow the formula. So 4 times 2 minus 4 times 3. So first we're going to multiply these two given, which is 4 times 2 is equals to 8 and 4 times 3 is equals to 12. So 8 minus 12 is equals to 4. And the important points of these topics where 0 is not a natural number. It is a whole number. And then negative numbers, fraction, and decimals are neither natural numbers nor whole numbers. And n is close, associative, and commutative properties under both addition and multiplications, but not under subtraction and division. While in distributive property, we can use a subtraction, addition, and multiplication. So any clarification or suggestion about these topics? So thank you for listening and about my report. So that's all.